Hi, Mackenzie. Hi, Emmy. Hi, Carter. Hi, Addie. Hi, Ben. Hi, Almo. Hi, Ava. Hi, Leon. And here comes Isaac. Hi, guys. All right. If you are just joining us one more time, the Nearpod is in the Zoom chat. Go grab it. So we're ready to start as soon as we get there. What are we doing right now? We're starting with Miss Mackenzie, our teacher helper this week. You ready?
Participate, be respectful, on time, microphones muted, include full name and Zoom, stay seated, eyes on me.
You went so fast. The computer went, wow. Awesome. Thank you so much, honey. Thank you for telling us our Zoom call expectations. It's a promise that we made to each other early on. You do not unmute unless you are called on. You participate. You're not playing around. You're staying in your spot and you're keeping your eyes on me. And of course, being respectful. Back to you, Miss Mackenzie. What's today?
Thursday, March 2nd, 2023.
Oh, perfect. Chef's kiss. Thank you so much. All right, guys, getting ready to start. Oh, I gotta let a friend in. Awesome. And our birthday celebrations for the entire month of March. We have a lot of people. We are celebrating Ruby, Viviana, Isaac, Frank, and Miss Cruz. Yeah. Thank you. All month long. We're getting older. Love it. Okay, guys. Weekly spotlight. Ava for being an awesome Zoom promise keeper. Yes, Ben and Olmo for amazingly detailed responses, and Asa for working hard. Ava, if Ava's here, you're going to be picking a game at the end of today's lesson, so we better hurry up. First thing first, Mrs. Cruz made a mistake. Oopsies. I was trying to solve this problem. 40 plus blank equals 50 plus 12. I didn't know how to solve it, so I just guessed and threw a number in there, hoping for the best, but you know what? That never works out as well as you think. So it's time to discuss. Grab a piece of paper if you need it. Oh, Mackenzie, I see your hand first. What do you think I did?
I think you put the wrong number in after 40. 40
Okay, so
plus, I know what it is. It can be 10. You just put in 2 more. You put in 12, and 12 is 2 more than 10. So that would be 52.
Oh, okay.
So you would need to change the green to 10.
All right, well, we'll talk a little bit more about that, but she definitely noticed that it's not the right answer. It doesn't appear to give the same value. Carter, share with us your thoughts, or talk to Mackenzie or any friend you'd like.
It would be wrong because 40 plus 12 is 50. And you would need to take away that 12 at the end and take away that 2 in the right next to the equal. Then it would equal 50 because 40 plus 10 equals 50.
So if I told you,
but if you added another 12 to it, then it would be like 62.
So Carter, if I told you that the only number that I could change or manipulate is that green number, I can't touch anything else. Talk to somebody about what you might do first to solve this problem. Who do you want to talk to? Pick a friend.
Mackenzie.
Okay, you and Mackenzie, unmute. What would be the first step?
You would have to erase the green number to change it to a different number.
Yeah, you would have to change it to a 10 to make it to 50.
Yeah.
But then what would you do with the 12 at the end? You would put that one, then you would make 62. But if you wanted 60, then you would take
You'd
away
have
that
to
2.
change that to 10 too.
Mhm.
if I'm not able to change anything else except the green number, it's the only number I can change. Okay, Ava, go for it. Thank you. And if you want to discuss with them or someone else, go for it.
40 plus 22 is 62. So the green number should be 20.
20. Now,
I meant to say 22.
where did you get 62 from? That's important. Why do I need to know 62?
It's because 50 plus 12 equals 62.
Is that the first step that I need to find out what is on this side of the equation? Was that the first step? I needed to find out what's on this side of the equation?
So I figured out it was 62. It's because the 12 has a 10 in it, and then the 50 has 5 tens. So the 10 in the 12 makes a 60. So if you add that together, that's 60. And then the 2 in the 12 makes 62.
Okay, all right. Now, here's what I want from you guys. What do you think step 1 is in this equation? Now, of course, I can erase this. I think I can pretend to erase it. I can draw over it. I can do something to change it. But for now, what was the first step that I need to figure out in this equation? Before I can solve for the green number, what do I need to do first? Ava, call someone. She already did it, by the way.
Addie.
Addie?
The first step is you have to figure out what 50 plus 12 is.
Okay, great. And Ava did that for us, didn't she?
Yeah.
All right, nice work, Miss Ava. Listen, and we can't balance an equation if we don't even know what's on the sides. We don't know what's on one side of the equation. How can we balance what's on the other, right?
I wrote this.
Ooh, look at that. So now, Addie, explain, what is 62 minus 40? How did you do that one?
62 minus 40 is 22.
Why did you do?
You know that the 12 is supposed to be 22.
Okay, call someone.
Okay. How about Emmy?
That's a terrible looking too, but I got it. Emmy, what do you guys think about the second step? She took the whole number from one side of the equation and then subtracted what was left, which was the only thing I know was 40. What do you think? Emmy, are you there? Hi. Did you think that step will help us find the answer?
Yes.
Okay, keep talking. I need more than one word.
So I actually just I'm trying to put a 40 and 60 together.
Okay, so 40 plus 62, but then what's this equal sign for? If we add those together, are we following directions?
Yes, because there's a plus sign.
But this equal is in the way. It's kind of like a police officer. He's like, no, you're not going to add. Stop there. So wait a minute. Let's talk about what's on this side of the equation. All right, let's see. We have 40 plus I don't know. And that has to equal whatever's on the other side of the equation. Whatever's on the other side of the equal sign, it better match, okay? It has to be equal. What does equal mean? Anybody know it?
The number?
Say it.
The same.
same. That's right. Whatever's on this side of the balance, I'll make a little teetering balance here, needs to be equal or the same as the other side. So we can't figure it out unless we solve the one side, right? Now what we can do, and boy, I have to erase all sorts of things. Ready, guys? Boop. And I'm going to cross this out because we know that's not right. You all told me that's not right. If we add that up, it's not going to be the same as this value. We had to solve step one, figure out what's on the completed side of the equation first. 62 was the total value. Reverse it, subtract what you know. I said reverse it. To find the unknown number, go backwards. Take the total number, 62, subtract the only other number you know. Instead of add, do the opposite. Minus 40. Let's find the difference. Who said it was 22? Who said it was 22? Ah, you guys are awesome. That is right. 62 minus 40. We're not going to take the time to show you how to solve it. You should know how to solve 62, take away 40. And you'll find that the difference will help you balance the equation. Now 40 plus 22 is the same and equal to the other side. Very nice. Thank you, guys. Thank you for helping me. Let's go on. Oops, I have to clear everything. So what are we doing today? That was just a quick warm up for your brain. Last week, we partitioned, cut into equal parts our circles. But you all begged me to do rectangles. So guess what we're going to do today? We are going to partition, cutting into equal parts, the rectangle. Get ready. After this, we are going to estimate and measure lengths of objects to the nearest inch, foot, yard. It's a short lesson, but next time we meet up, I want to do a quick lesson on measuring to the nearest inch, foot, yard, centimeter, or meter, and using the appropriate tool, because I've noticed that some people aren't quite sure what measuring tool to use. All right, let's play. I'll meet you over in the Nearpod. If you have not seen the Nearpod link, it's in the Zoom chat. Let me meet you over there. Let's get started right away. Thank you for helping me solve that problem, by the way. I do appreciate it. Solving for the unknowns. First, we figure out what's on one side of the equation. Then we can subtract the part we know from the whole. We can reverse our equation and find out what the difference is, so we can know what the unknown part is. Part whole. All right, loves, let's do it. I see 7 friends in. I count Viviana, Isaac, Ava, Almo, Ben. That's 5 people. Then I have Addie, Carter, Emmy, and Mackenzie. I have 9 friends in my Zoom call. Nope, 10 friends. I've got Asa, Feyruza, Leon, 11. I have quite a few friends, but you're not all in the Nearpod yet, so keep trying. I have 8 friends in. How do you partition rectangles? Okay, quick poll. What do you already know? How much do you already know about partitioning rectangles? I know a lot. I can explain. B, I know a little bit. I need a bit of practice. C, what are rectangles? I don't know. Help me partition. I need a lot of support and instruction. Choose your answer in 5, 4, 3. Let's see who's not in the Nearpod. Oh, Carter's there, Ace is there, Leon's there, Ben is there, almost there, Mackenzie's in, Emmy's in, Addie's in, Ava's in. Oh, Isaac, are you joining us? Viviana, are you joining us? Awesome. Okay, all right, I'll wait for you. Wonderful. So you guys already know about partitioning rectangles? Let's see. The first thing we're going to do is go through a very quick slideshow of all the definitions, the vocabulary words that I would like you to use when you are not only in your DBAs with me, got to use the big words, but also in your responses and when you're speaking about it. So here are the words. Column. Everybody make a tall column, skyscraper, tall column, way up, all the way. That's a column. It goes up and down. It's vertical. Why am I showing you that? Oh yeah, because like in a chart or a graph, the column is the one that goes straight up, okay? And we need to know that because when we partition, we can divide or cut our rectangle into columns, straight up and down, vertical. And then if I skip to the last one, guess what we can do? We can also go, what's the other way? Instead of a column, we can do a row. Think about rowing your boat. You're going flat. You're going straight. It's horizontal. So it's a cross. All right. Then what else do we need to know? Equal shares. Equal means, everybody unmute on the count of 3. What does equal mean? Say it. Say it.
The same.
The
The same.
5, 4, 2,
Same.
1. Awesome. You guys are amazing. All right. Now, fourths. With your fingers only. How many pieces is fourths? 1 piece, 2 piece, 3 piece, or 4? Yep. If you said 4 equal parts, that's what fourths are. Also known as quarters. You're going to hear me say that both ways. And there's a reason for that. I'll tell you why in a minute. Halvesies. Show me how many parts are halves. How many? 1, 2, 3, 4. If you said 2 equal halves, half for you, half for me. 2 parts. Excellent. They must be equal. What was this one? Where's there's not there. Show me thirds. How many are thirds? Sounds like thir. Check your fingers. Check your fingers. How many parts? 3. That's right. Sounds like thirds, 3, thirds, 3. Sounds like 3. All right, the next part is partition. Give me your karate chop. Hi. Yeah. We're partitioning. We are cutting and dividing and cutting and dividing. Like a delicious pizza. Rectangle. We already know what a rectangle is. Let's see what it says. A rectangle is a fuzzy object. No, that's not what it says. Oh, there's somebody's showing me a shape of a rectangle. It is a 2D, 2-dimensional shape. That's right. It has 4 sides, but 2 sides are long and 2 sides are short. It also has 4 vertices. Yep. Is it a polygon? Nobody knows what a polygon is yet. All right, we'll go over that another day. All right, match each picture with the word it represents. Guys, I need to know if you learned about the vocabulary words. So get ready. Match fourths to the picture of 4 equal pieces. Match row your boat to the picture that shows a row across. Match halves to the picture of half for you, half for me, equal parts. Match the word partition to the cutting into equal shares. Match the word column. That starts with a C, column, with the tall column. Okay, part that goes up and down. When you divide, you can cut into columns, divide, partition into columns. Then we have equal shares. Just match the picture of the shapes that have been divided into equal shares. And the last one, y'all know what a rectangle is? I hope so. How'd we do? Oh, look at you guys. All right. Yep. Here come the answers. Oh, amazing. Ava, Addie, Emmy, Mackenzie, Olmo, Benito, Leon, Asa, Carter, and here comes Isaac's answers. I love it. Nice work, guys. As long as you understand, partitioning is equal shares. Now, what are we doing now? It's thinking. It's thinking. Your pot is waking up, guys. I hope we don't have to skip this part. Good. All right. Can you tell me what equal means? What does equal parts mean to you? Type that word in. You know I love. Explain what equal parts means. How do you know if parts are equal? Ooh, I can't wait to see if everyone remembers. Hi, Fayruza. Go ahead.
My Nearpod is not working.
No worries. You can type in the Zoom chat for me, okay?
Mm-hmm.
All right. Thank you, love. All right, guys, I am checking all our, yep, look at all the answers. The same, the same, the same, the same, the same, the same, the same. Everything's the same. When you partition, or just like when we did our unknown math problem, equal has to be the same on both sides. Has to be equal and fair. The same. Great job, guys. All right, moving on. I'm so glad you all know that when you are dividing shapes, they also need to be equal shares. All right.
You get to send my report.
Leon, are you going to unmute for me? I hope not. Thank you. We are going to move on. Look, we're going to eat some sushi today. Who likes sushi? I love sushi. Where do you see rectangles in the photograph? Okay, I see rectangles. Do you? Who wants to talk about it? Pick a partner. Asa, who do you want to discuss with?
Ava.
Ava and Asa, unmute and quickly name as many rectangles as you can see. Go.
Okay, the rectangles I see is the fish things. They kind of look like meat, and also the celery things that are
Great.
above it.
Okay, go for it. Who else? Asa.
I see seaweed and hands, some bread head right below the seaweed. That
Okay.
looks like a rectangle.
Ah, all right. Nice work, guys. Thank you. Thank you. Thank you. Who else wants to go? Who else sees some rectangles? Let me see. Olmo, pick a friend.
Benito.
Okay, go for it, guys. Do you find any other rectangles?
I see the seaweed. I see the fish.
Okay, we got those. Yep. What else?
I see the shrimp.
The shrimp are rectangles. Are you sure they look like rectangles or triangles?
They kind of look like rectangles.
Yeah, they kind of do. See anything under the food that looks like rectangles?
The plates they're on.
Oh, do you agree, Ben?
Yep, I agree.
Yes, nice work. All right, guys, thank you. What if we had to divide those up? What if we had to share equal parts? Let's find out what happens when we have to divide a rectangle. So this is kind of a funny, quick, funny video. Let's watch. I think it's with brownies. Oh, who's not muted? Let me find you. I'm gonna eat you like a brownie. Thank you. I think it's brownies. It's either brownies.
In today's lesson, you will learn to break a large rectangle into many smaller, same-sized squares.
She means partition.
So, my mom and I decided to make brownies to celebrate my birthday. We used this pan that is 3 inches by 4 inches. I want to cut this pan of brownies into smaller, square-shaped pieces that are all the same size. Are all these pieces the same size?
What do you guys think? Shake your heads. Look at you. You're like, no. What if you guys got this little piece right here? Is that fair? That tiny one on the very top right? And I get this big, yeah, no, that's not equal.
No, why not? Do you think these 2 pieces look like they're the same size? No. And are both pieces squares? No. Remember that for a square, all 4 sides must be the same length. Okay, so are these divided into equal sized square pieces?
No.
That's because these pieces are not the same size, and neither piece is a square. Remember when we said that the pan was 3 inches by 4 inches? Well, let's try this. Why don't we divide the pan of brownies into equal-sized square pieces using rows and columns?
Rows, columns.
What's a row? A row is when parts of a shape go across. Here, let me show you. Let's try breaking this brownie pan into 3 rows, or 3 pieces that go across. 1 row, 2 rows, and 3 rows. This can sometimes get confusing because we only made 2 long slices, but now there are 3 long parts, 3 parts that go across. And remember, we call these rows. Now let's divide our brownie into columns. What's a column?
Show me your columns.
Columns are parts of a shape that go up and down. Let's divide our brownie into columns. I'm going to put columns on top of the rows that I've already cut into my brownie. I will divide my columns with the color white. We've got 1 column, 2 columns, 3 columns, and 4 columns. Remember, this is the part where it can get a little tricky. We made only 3 cuts with the white line, but we have 1, 2, 3, 4 columns.
So the takeaway from that is don't count the lines, count the columns. Okay, that's what they were just trying to say. I only drew 3 lines, so then I only have 3 columns. Not true. 1, 2, 3, 4 columns. If you drew, it doesn't matter how many lines you draw, it's how many columns you draw. Okay, moving on. Now that you know the difference between columns and rows and how to divide yummy brownies in math, partition, show me your karate chop. Hi-ya, means to separate a shape into smaller equal pieces. On the next slide, you will learn more about partitioning. Pay attention on how to partition into equal size. Oh, I see my chat. Thank you, Ava. Thank you, Carter. Now, same size squares. These rectangles have been partitioned into same size. That first example. What's up with the second example? Have these rectangles been partitioned into same sizes? Why not, Fayruza? What's wrong with them?
Because I see on the top, the rectangle, it's a way bigger square than this little triangle down there.
That's right. And is a triangle a square? Is
No.
a triangle a square? No. So whoever did this didn't even follow directions, in the sense that they didn't make them into squares. They cut a triangle. Thank you, my love. All right, let's keep going. Rectangles can be partitioned into rows and columns. On the next slide, you'll learn more about partitioning. Hiya! Rectangles. Pay attention to how to find the total number of same size squares. This is a rectangle. This is the same rectangle divided up. Looks like a cake. And it's divided or partitioned into rows and columns of same size squares. Rows go left and right. Go ahead, row your boat straight across, left and right. Columns, build your columns straight up and down. We got that. Good. You can count to find the total number of same size squares. Remember, you're not counting the lines, you're counting the columns that you make. This rectangle has been partitioned into 12 equally sized squares. Now it's your job. Partition the rectangle into rows and columns of squares, not triangles. Then count to find the total number of same size squares. If you need help, you have an example right here. Yes. Okay. So once again, your job is to divide the rectangle into equal parts, equal squares, and then count to find the total number of same size squares. How'd we do? Whoa! Are they equal? Are they the same? Would you be okay with getting the tiny little piece down here, Ben, on the very bottom? And then I get this big monster piece up on top. Remember, it's easier to draw one long line than a bunch of little tiny short lines. Oh, Leon, that was looking good. Oh, Addie, that looks great. It's hard to draw equal lines on Nearpod, isn't it? Yes, it is. Oh, yeah. Okay, I see it. I love how you numbered them too. Olmo, that looks great. Okay, let's go back and look at the example before I do mine. They want us to do rows and columns. And they all have to be exactly the same size. Oh goodness, it's gonna be hard. Let's see. I wonder if I can I do it? Let's see. Ooh, yes. All right, here I go. Oh, I think the hardest part is choosing how many I need. Whoa. Did you start easy like me? 1, 2, 3, 4? Or did you go ham and do like a lot of pieces? Okay, so I went easy. Didn't I go easy? So I have 4 total number. But you guys, you tried something else. So let's see if I can do what you guys did. Is there an easier way to do this? Yes. Okay. Now, I see what you guys did. Let's double check. Can I do blue? Blue's pretty. Straight, straight, straight. Oh, this is hard. Straight. And then straight, 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 straight. Ooh. And now I have 3 rows. I need columns that are equal sized. I could just go straight down, couldn't I? Can I do that? Let me show you that. Whoa, right down the middle. How many pieces are equal, guys? Count them up. 1, 2,
3.
Yay! You said 6.
1, 2,
That's another way to do it.
3, 4,
What if I
6.
Thank you. Don't unmute yet. What if I cut this side straight down? Oh, I have to be so careful to make sure it's same on both sides. Some of you are real artists, so it might be easier. Okay, count the sides, guys. I mean, count the pieces that I divided. Yeah, did you see that too? Okay, so now, oh, it's not going to erase for me. Okay, fine. Fine. I got to do it this way. Don't mind the fact that I drew past. That's just so I stayed, you know what I mean? Like I stayed straight. Okay. How many how many pieces are equally divided and partitioned? Fayruza did it. Fayruza says 12. Okay, let's see. Who else has an answer? How about Isaac? Isaac, how many pieces did I partition? Ooh, somebody says 11. 1, 2, 3, 4. Go ahead, Isaac.
12.
Let's see. Yes. And they all look nice and equal. In other words, nobody's going to be sitting down crying saying their piece is too small. So that's the most important part. We don't want anybody upset that the pieces are cut unequally. Let's revisit the photograph of the sushi. Find the seaweed. Everybody loves that green seaweed. How can we partition the seaweed? Go for it. I want it into same sizes, but you don't have to do 12 pieces. Make it easy. How many pieces do you want to cut this into? What equal shares? Oh, I like that. Equal shares. That reminds me of something that you need to know this to help you work on. It's called fractions. I did promise that I would tell you why you need to learn about equal shares. because we are going to use this knowledge when we are learning about fractions. Ooh, nice work, Fayruza. Excellent. I love it. This, ooh, look at that. Very nice, guys. Emmy, you have 4 equal pieces, as equal as we can get on your pod, right? And Olmo, yes, 6 pieces. 1, 2, 3, 4, 5, 6. I like your, you have 3 columns and 2 rows. Nice work. Ooh, Carter, that looks awesome. I know, oh my goodness, Isaac, look at that. Yep. Oh, I like how Carter's numbering them. So is Benito. Addie did hers. Okay. Was it harder to do more shares or fewer shares? What do you think? Viviana, have you tried it? Do you think, Viviana, it would be harder to do more shares or fewer shares? In other words, is it harder to cut it into a lot of pieces or just a few pieces?
Just a few pieces.
Might be harder to do just a few, or is that, maybe that's better? What do you think, Ava? Is it harder to make a lot of equal shares? Yeah, she says yes. It is harder when you have to cut it into multiple pieces. What about you, Emmy? What do you think about dividing it into a lot of equal shares? Is it hard or easy?
It's that hard, but
Not hard.
it's just
Is that
it's so
seaweed?
crazy.
Is that piece of seaweed, Emmy? Is that green piece of seaweed square or rectangle?
Square.
Isn't that weird that we're dividing a square? Is that easier to divide a square or a long rectangle?
I think it's easier to have a square.
Me too. And I've noticed that too. You guys did a great job partitioning your squares. All right, finally, a quick quiz. Oh, we're very close to the end, guys. First question. Look at this picture. Is this divided and partitioned into same size squares? Yes or no? Fayruza says nope. Okay, let's try the next one. How many same size squares has this rectangle been partitioned into? Count them and tell me how many shares. Fayruza says 2. Ava says 2. Next question. How many same size squares has this rectangle been partitioned into? Count the equal shares. Is it 2, 3, 4, or 6? Ooh, look at those answers. I like it. Yep, I agree. I agree. And the next one. 2 more. How many same size squares has this rectangle been partitioned into? Count. This is number 4. Count how many equal shares that has been partitioned into. Great. Yep, I agree. And the last one. Okay, get your counting fingers up. How many? Has this rectangle been partitioned into 5 equal shares, 10, 15, or 20? Oh, goodness. Oh. Yep. Thank you, Carter. Ooh, let's see your answers. Wow, look at this sea of green, guys. I love it. Let's count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 equal. Nobody's crying in the corner. Shares. Very nice. Now, following today's fabulous math lesson about partitioning rectangles into equal shares, how confident do you now feel in your ability to explain how to partition a rectangle into equal shares? A, very confident. I can explain, I can demonstrate. B, I'm getting better, but sometimes I don't get the shapes. I don't know, maybe I need help. And C, help. What's a rectangle? What is a partition? How'd we do? Ooh, more people in the A. I like that. Couple people still need some practice. That's wonderful. Couple more people, I'm waiting for their responses to let me know what I need to work on with you guys. That's why we do these polls. It gives me an idea of what you might want or need help with. Okay. Think about what you need to know. Awesome. Thank you for learning with me. Yeah, great job, guys. Oh, thank you, Fairuza. Thank you. And it's time for Ava's game.